Hello, you beautiful people, and hello, Groq community and Groq itself. As I promised, I am recording the video here to explain my code base, and repository now is available for everybody, and everyone must welcome because I haven't done that much of testing, so definitely there are some bugs, and if you figure it out, you can make an issue. I may try to solve it or ask you to join me and then do that because really I want to invest on this project. And as you know, the motivation for me was the Groq itself, and having this function called proxy is a must. I think is important. But when I did it, when we used it internally with my company and projects, it's so good that I wanted to share with everyone else. And now, in my mind, is much bigger than that. It can be a lot better than what I'm doing now, and I want to talk about it quickly, and then let's see how it goes. Anyway, as I said, I know I have this simple web page to explain how you're going to communicate with all this kind of APIs that I added into proxy. And I created a Colab. Let me go through the Colab quickly, and then we go to the code base. So basically, there are what we try to do is we have this proxy, right? That we want to use it and then to communicate with Groq and let the Groq understand what tools should be in the games, and then we run it and pass the results and get it back by following the API interface, which became sort of a standard after OpenAI, which that's really like it because then we can mix it with libraries, someone such as Llama Index or LangChains or PhiData, which is my very popular library these days. Make sure give it a check, go to their GitHub, star it, and follow it. It's really nice. It's the one of the best way that I can see that you can create assistants and then use it. So in this Colab, I have 4 ways, 4 concepts to see that how you can communicate with my this FunckyCall.ai, the funky function call. Anyway, the first is sending a simple post message request, just something that you can use it natively, just simply. So what do you do is I already explained them in another video. Just quickly, just go through them. Here, I do have this DuckDuckGo search because I want to have the ability for search over the websites and search over news as well. I'm following the example that I faced with it first time when I was working with PhiData. Here, there are a few things. I have the API key for the Groq, so I'm passing over there. So I have the header. And then I have the proxy URL. So this is very important. Look at that. It just follows this version 1 chat completion. And you notice that they have this one. I call this provider. Later we talk about it. And I have these 2 functions. And I have requests, typical, always the schema stuffs. And then I give a call, request. Then I results, my result this time, because the proxy server augment the response from the Groq, and then now you have 2 calls. If there is 2 calls, you go through it, maybe multiple calls, and then you call them back, get the results, add it back, and then again, second time you call and you get the results. So this is just an example that I've done it here. This is the first approach. Okay, cool. You can really work with it and use it everywhere you want it. Now we go for the second one, which is a schema list. This is what I really love it. When you want to pass all those kind of a schema, it means that you want to add extra information, the JSON, to let the model to decide, right? Basically, you can use even the YAML structures, whatever that model trained for that. But then when you get the response, you have to execute those functions on your own computer and your own device or machines or whatever, then add this response back, and then again, second time to call it. But wouldn't it be nice if somehow when you send this request to the proxy server already has million of functions, which you just pass the name, and then the proxy server, when those functions available, by itself execute them, and then put back the response into calling the large language model again, Groq in this case, and then give you the response, the final response. In this way, you save a lot of times you get the benefit of the standardization in somehow, and you have flexibility. And also imagine if one day I can make it into a kind of hub, which I call it FunchyHub, and then you guys come and help me. We can have a lot of functions. So let me show you how it goes. Everything is the same as before, but look at here. This time there's no any schema. I'm just passing a namespace style for the function name. DuckDuck.search. So DuckDuck is like a category, is a collection, is a module of functions. And then I have search, I have news. That's it. And then when I call the proxy, I have everything. Finish. Because proxy detect these functions as a built-in function and resolve them by itself. Typically, when you call an endpoint like OpenAI, those function tools are unresolved. I call them unresolved. That means you have to call them and put it and resolve it and then put it back. But that's the benefit of it. So I really love this. It's very helpful for my projects in the company. It's beautiful. I bet you're gonna get used to this one. But for now, I don't have that much of functions in this. If you like it, you join me. We work on it and we add a lot of functions. There's gonna be a million of functions, all the functions, the planet Earth and other planets and other galaxies, like my hometown galaxy Andromeda. and then and then you're gonna get it here. And then finally, the third is let me go to the fourth. Maybe I should go to the fourth first and then go to the third. I have to change them. This also is because there are situations that some of the functions are available on the proxy, so you want to be run there, and some of the functions you want to run it yourself. So some of them are going to be resolved in the proxy server, some of them are going to be resolved on your side. And oh, okay. And then that is possible. What are you going to do? You see here, I have the function, right? So my function map it has only one. And then here, I pass the schema same as before, but for the other function, I just pass the built-in name. Then I call the proxy. When proxy back to me, again, I check that tool calls exist, message content is none, but this time I have something new. If there is a key resolved in the rest, this is not the typical key that you see in response from OpenAI or anything else. I just added it, you will see that. If there is resolved, it means there are certain messages relevant to the tool that you pass, duck.news, are the resolved. So what are you going to do? You're going to add it into your message. You add that rest resolved. It depends on how many tools you call. It's a list of them. So that's why I use the extend. And then you go through the rest of the tool calls, those that you have to resolve it. So you do it, you run it, you pass it, and then you call again the LLM, and then it will get the response. So that's resolved and unresolved. Okay. And then finally is the PhiData or similar libraries. It can be LangChain or Llama Index. And in the PhiData, I just import OpenAI like, which allows you to connect to anything OpenAI with the OpenAI interface. But look at the base URL is not that doesn't have the chat completion because PhiData will add it by itself, and other libraries they do the same. And I created an assistant and I run it and I get this beautiful markdown structure. And I really love what PhiData, the way PhiData responds the information. So good job, guys. And that's it. So 4 ways that you can do that. So with this review, we are, I think, ready to talk about a code base. So I go to the code base. Maybe I open first the repository here. You can see that. Okay. I'll go to the app folder, and I do have roads, which for now proxy road is important. I have config. I have nothing there. Models not yet. So prompts is important. Provider is important, and main. And I'm going to talk about them. But first, I'm going to jump to the chains. And you notice here I have functions. Here is the place I have that duck.py. Within the duck.py, I have search function, I have news, and maybe I have other functions in the future. And I use reflection to dynamically load those functions and run them. And I use class pattern. So each function is a class. You'll see it later. So let's go through the chains first. I practice chain of responsibility. One of my favorite Gang of 4 design pattern, chain of responsibility. It's like middleware in Express, in Node.js, or Fast API, or Flask. You have components. Each one is a handler, does something. The first one get the data, process, shake it, and then it produces some response for the next components and the next components. And finally, at the end of the pipeline, you get some results. But the interesting thing is we have a variety of this chain of responsibility. Some of them that decide that it's enough. Let's get back the results and extract it and give it to the end user. So that's exactly the benefit of it. And also they can have a fallback at the end. That means if none of them works, anything's then the fallback will do something. And if error happen, all of them goes to one other components that handle all the errors. It's beautiful. It's so good. It's like a Lego. You can change. You can create multiple version of pipeline for yourself. So, well, here, one thing is very common is we abstract the received data into an object, which this object will be injected to all these components. And these components can communicate and can read and write and change it. Somehow that's a state, which is sharing between these decoupled uh, uh, handler. And the rule is these handlers shouldn't know anything about other handlers in somehow, okay? But sometimes you can do cheating always. Oh, well, we go for the first one. Is context. Context is the one that process the received data. This context is very important. One challenge for me is to make sure do not mess up with the way that you are going to call proxy server API because it should be exactly like those OpenAI standard. And that's how it's going to work. So here I get the standard request. I get the provider. Provider is that Groq that I told you in remember here this proxy is Groq. So why I get the provider, you will see that. I tested because I wanted to see if I can use the same mechanism on other kind of providers, including OpenAI itself and Olama locally in my computer. It works perfectly. But no one is as fast as Groq. So we go here and then I did some sort of processing. I'll try to explain. First of all is because, as I said, the coming data follows the standard of the OpenAI. So I have to take out some of the keys and build something in my own internal representations. Here, for example, I take all the keys from the body. Body means the data game, except the messaging tools. I keep messaging tools in a separate place. And then for now, I set the params is stream is false because this params contains extra parameters that you may pass, like temperatures, like top P and other stuffs, right? But messaging tools, I take it out. And then I keep them here, self message, self tools, that's it. But I will work on a stream. Well, honestly, I don't know when you want to work with the Groq, you need the stream or not. It's changed the mindset of a community, I guess, this Groq. But anyway, I'm gonna establish it. I'm gonna put it there. Then, as I told you that when you send your functions, some of your functions are built-in, and I call them built-in tools, are those that there is no parameter in them. No parameter. Look at this, there is no any parameters because you must have parameters to put the JSON schema in the way that OpenAI wanted. Why I didn't do it in an easier way, maybe I just put functions names, keys here, because if I do that, then it doesn't match with the way that many of these libraries works and communicate. But of course, if you want to use this one, you have to go through um, the post request. Maybe I communicate with the guys in PhiData. If they like it, we can embed it together so you can use that one as well. So I wanted to not manipulate too much the structured request. So what I did, I just don't pass the parameter. And then here, where is it? Okay, so those, they don't have it, I call them built-in tools. Also, they keep their names into an array because they need their name. And the rest is custom tools. I should call them unresolved tools. Anyway, custom tools, those custom is those that they do have these functions and want to detect it and then send it back to the user. And then I went through those built-in. What I did is I take out their name. Remember, the name is like something like .use or .search. And then I split them. There are a lot of try and catch and error control that I have to do in this code, but I haven't done it. So that's why I'm saying it's very suspected to have kind of errors. But we will improve it. There's no perfection. Perfection is one point at the timeline of the progress of getting better and better. So now I'm at the very beginning. And then, so I split it and then I create this function name. I'll tell you. So see if it's search, function class name, search, uppercase, search function. So this is a class name. And then I load this one from this library, app.functions module name, which in this case, module name is duck. And then I have the module. Then I get the class name out of the module, which is now the class objects, and I create an objects from that class. And I have now I have this fun class. Okay, I get it. So let me pause a little bit here and jump to this provider class. Remember I said provider, right? Here is provider. Okay, the provider. I think I have it somewhere here. Let's see, do I have it? Yeah, here. This is the provider class. There is a base class, which base class is simply has getting API key, parser model, and route model. I'll talk about them. And the route functions. The route is the one that send it to the LLM. And there is a clean params. I'll talk about it. So let's go for Groq first. I do have, so first I create the clients. This client is important, the one that will pass. And then we have parser model, rote model. Parser model is the model that I use to uh, extract the JSON response to know which functions are going to be used. Honestly, when I created this, I use one of our own fine-tuned model with my private data in my company, which we designed it to just respond always JSON. That's what we needed. So we wanted to train it. So we fine-tuned it. And then I have a rote model. So rote model is the one that handled the conversation. So at the beginning, I used that model. And for the rote model, I use Groq. Everything was perfect because I knew that model works well. But then I decided to do some prompt engineering and some interesting stuff. So I will show it to you. And I replaced it with Groq itself. It works perfectly and fast and no problem as of now. So that's it. So we use this. So you have this ability to have two different models for doing different things. Who knows, when Groq come up with the 2 billion parameters, I will switch with that one because it's enough. And then we have these exclude parameters. Honestly, the exclude parameters is just some sort of manipulation here because when I transfer this data into um, the client, in this case is the Groq, I have to be sure that I don't have those informations that Groq doesn't understand because this tool choice and tools are for that, function called API for OpenAI. So I have to take them out. So every provider has sort of things should be come out of it. And messages always is part of it because I don't want to send a message. I want to do something on messages. You will see later. And as I said, I did also for Olama. It's very cool. It works nice, perfectly. It's a very local. I use 2 billion Gemma and 7 billion. I tried with the Mistral, all works well. With Orca, nice. Okay, so now back to what we were saying. So now, oh, I forgot to talk about this. Uh, let's see. Where is it? Okay, so that was a provider, right? Let me see. Oh, I shouldn't explain provider. um, okay, excuse me. We're talking about the function name, duck.news, okay, and duck.search. Provider, I want to talk about it a little bit later. Okay, so excuse me, okay, please. And then here again, let's just Ctrl Z, Ctrl Z a little bit. Here we get that duck.search. So we take out a duck, and then we take the search. We make the search uppercase capitalized search function, and then we go to app.functions module name, and then we take it out. So let's go back to the function. So the function is duck. So I'm going to go to this duck.py. I think I have it somewhere. Okay, I'll open it again. So I'll open this duck.py. So now I am here. Let me close these things. Okay. There is a base function. I shouldn't keep it here. I should keep it into another class. But anyway, so the base function is like this. Every functions that you want to define, every function class that you want to define must have a name of the functions, textual description. It has another class, we call it a schema within the function, which is the schema. It's a pedantic model that explains the function. And there is a function class method get a schema, which returns back this one. We want this, right? We like this one. So that's a trick. Let's take a look at the one of them and then you understand it better. So let's look at the duck.search. So that's the name, duck.search. And you see the search, that's why I make the search uppercase and connected here. This is a description. It has this schema and it has this run method. The run is what we running in the proxy, not in the client side. So in this case, I create an instance of search, Google search, and I search it and I return back the result. So the point here is these are functions running in the proxy. And imagine we can have a lot of them, and that's my plan. This is actually the FunckyHub. We're gonna have a lot of functions over here, like this search, like this news, that is just do the same things. They have descriptions, a schema, and that's all. And then when you call this, I back here, I create the function class. I call the get schema, and now I have the schema dictionary. So remember that when I was calling, the function has only this. But after this, the function will get its schema value. So again, I get the duck.search, I pick up the duck, I pick up the search, I go to the modules by dynamic import and then bring it out and bring the class. Class has already its pedantic model in it. And as I get the schema function, so I call the function to get the schema, I pass it here. And I have this run function. Run is the function that I mentioned. So I pass it to the built-in. So now built-in tools, they have this extra keywords, run, which is the functions that we have to call it. And I have self.clients for now is none. Client is going to be provider, which I made a mistake. I talk about it. I was so enthusiastic when I was explaining the provider. But anyway, and then I have these functions. One is the last property, not functions. The last message, which returns the last message. And then, you know what? This is what I do. When you send a request to proxy, you may send a normal request, nothing, just a normal request. You may send your first function call request, or you may send a response. It means you executed the function calls and you injected the data and you send it back. So I created this property to tell me which one is which. For example, is tool call. It is tool call request if the last message role is user, because it's the first time we're asking the proxy to detect it. And then, but there is tools. There's a tools in the request. So you see that is this is tools calls. But is it tool response? Is tool response is the moment that you send it back to the client executed, added those messages. But now the last message role is not user, it's tool. So I have to do this to be aligned with the way that other library communicate with the OpenAI. And then self tools. And if none of them is a normal tool, just a normal chat, I pass it. So this context is very important. So again, it extract those important keywords that we use them as an options and pass it to LLM, like temperatures, top P, and this and that, and then try to process built-in tools if you send any, and then call them dynamically, import them, and then send it and prepare it. So now we have this context. Let's go to the first component in chain of responsibility. All these components, they instantiate from this parent class. This parent class has one important function. Handle is the abstract method which we will implement it in these functions. Why? It's a lot of things. Okay. And then we do have this set next, which when you create the components, you want to create the next chain. So you say next, by set next, you twist them, make them connected, and then you can play around with it. So we go with the first one, which is the provider selection handler, which I already explained the provider. So it's going to be very easy here. Let's look at the handle. I get the name of the provider. And remember, the context has the provider, which comes from the URL. And capitalize like Groq provider. And then I import the module and I get the class out of it. And if the class exists, I create an instance of that class. I pass the API token. And then I say, hey, go and handle the next part. So this is what this comes from the parent class handler, which get the handle, and the handle goes to next one. Let me see why this. Okay, so look at the handle. It just check that if there is any next handler, return next handler handle. And if something went wrong, you see that they have very special handler. I call it exception handler. So it doesn't do anything. It just return a proper JSON response with the error 500. And then here I'm using it. I'm just returning it away. So this is a nice thing about a chain of responsibility. And I'm doing this in the handler, in the parent class. You see, it's much better. So back to the provider selection. So when it's there, I just pass it and I go to the next one. Otherwise, some errors will happen. Well, we handle it. So that's the provider part. So provider instantiate the clients, and now context that client knows it's Groq or Llama or anything else. Now we go to the very important part, the tool extraction handler. Well, there are a lot of things that we have to consider here. One is it can be a tool response. It can be a tool detection request. So this is the part of the extract tool. That's why first I check that if context that is tool call. Is it a tool call? If it's a tool call, then I go and I do this. If not, I'll just return, pass it to the next components in the chain. Maybe it's a normal call. Maybe it's a response call. So I don't care. And now I go with this. So first of all, let me tell you a little bit about my strategy. Remember I told you that I started with a model, a model which is fine-tuned. but that is with the private data. I can bring it here, but maybe we do a fine tune with public data, and then we release that one also in the repository so you can use it. But now listen to how I handle communication um, with Groq. Okay, there's these things that I have seen many times, many places. People come up with weird, sometimes weird techniques to force large language model to generate the response in a very specific format. One of the good example is JSON. For example, let's say we have some data. We want the LLM to generate a kind of response based on what we wanted. But then there are a lot of kind of hiccups and then glitches, and then we have to fix and do that. But there is something, to me, large language models are expressive creature. They like to talk. They want to talk. Their job is to talking. Their job is to keep generating tokens and talking and generating and explaining, expressing themselves. Imagine if you have a child, especially those early ages, they want to talk. They want to express themselves. They're understanding the universe. And if a parent forces them, you should just only doing this and that. That's a totally wrong approach. But the better approach is let them to talk. For example, you want them to reach to a kind of a specific conclusion, but you warm up, you ask them to talk their ideas and this and that, and then eventually they reach what you wanted. And large language models are not much different in that sense to my experience. That means if I want to get that beautiful JSON out of it, instead of writing a system message, you only respond in JSON. You never say anything else. Then if you do that, I will blow up you and your data centers. And not going to work like that. They want to talk. So better way is to tell them, think step by step, as you know, which is one of the popular way. Think about it. Don't worry. Just bring it out. But at the end, tell me the JSON that reflect to what you tout. This is a different approach. I'm going to show it to you. In this way, they will do it perfectly. Look at the prompt that I used. Okay, this is the prompt. So I have a system message. I have a cleanup. I have a suffix. I'll talk about it. I'll go through it, all of it. So this is very important. You know what I'm saying in what I try to create. I pick up all the conversations and I merge them and I make the conversation a story, because I think we shouldn't just look at the last message. We need to look at least the 10 or 20 message before that. So there's a conversation. So I generate a prompt. I inject the conversation story, the last message, and then I ask the model, hey, think step by step and justify your response for the JSON that you have to, for the tools that you have to select, because I forgot about it. So first I put the conversation, then I put the information for tools, those JSON schema. Then I say that, okay, this is the questions. You're going to tell me that based on the conversation, which tool or tools we have to use, or maybe nothing, but justify, talk about it. And then when you talk about it, make sure at the end, generate your JSON response wrapped between this and this. So you see what I'm doing? I encourage the model to talk. And when it comes to the Groq, it's super fast. That's the benefit of the Groq that I can do. It makes sense to do that. And that's the benefit, and that's what I've done it. There's one more interesting things. I'll back to that about a system message. So in the system message, I explain, I say you can talk, you feel free, my dear, you can just express yourself. So we're back to, really, it's like a child, trust me. I think large language model, when we start to work with large language model, gave us the chance to become more philosopher or psychologist. It's really interesting. It's really interesting. So those skills works better than just computational skills. We have to understand this paradigm shift in the shifting the way we think. So anyway, what I did here, I get all the messages, and then I took the tools JSON here. So I have the tools JSON, and now I create my message. First is a system message. Then look at my next message. This can be user as well. Not necessarily to be system. It can be user. I'll try it. So conversation is story, then tools. And then I have that suffix, the suffix that says that, okay, think step by step and this and that. Now I pass this stuff to my function self.process tool calls. Let's see what this function does. This function is basically now, no, you see context.client. I don't care is what is a client. I just pick it up from the context. And it has a function route. I pass the model, which model, context.client that passes their model, because the model that I want to do that. This allows me to use that fine-tuning model as well. So with these parameters, and then I get the response, and I check that is there any, the JSON delimiters in it or not. If there is, I replace everything and then bring it out, and then I turn it into a JSON. That's it. And if there is a kind of error, that's what I do. And I figured out it's beautiful, although almost doesn't make mistake. But if happen, what I do is I take the error message, add it to a new message. I keep the previous conversations, and I have that. Uh, Remember the cleanup. The cleanup. You see, from your last message, please return only the valid, whatever. So this cleanup message is telling the model that you made mistakes. This is the errors. Just help me. I want to extract the JSON from your last message. So sometimes it is, and this is a very helpful thing if happen, especially the models that they're not good. And then I will try it, and the second time definitely works. But when I test it with Groq, it always take it immediately, instantly. So that's just a process here. And then I go to all the kind of tool responses, and I add them to tool calls in the structure that we know it all. The structures is familiar: ID, type, functions, names, and arguments, which is coming from here. And I return it back. So back to here, we are in the tool extraction. So I got the completion and tool calls. And then if there's only tool calls, something is wrong. Now I go to the part of what if there are tools, built-in tools, and some. So what and what are, and there are some also unresolved. So I want to support both. Okay. First, I created in the way to just support built-in, but then I changed my mind. I want to have both because we need it. So here, first I go an unresolved call. Unresolved call are those tool calls that their name is not in the built-in tool name. That's this kind of things. So now I call them unresolved. I will back to them later. Then now I go through all these tool calls extracted by the LLM, those tools that we have to call. Then I figure out which one is in the built-in tools. Then if the name is equal with one of those built-in tools, I can actually code this in a bit better way, but with the least comprehension. But if just let's do it. I wanted to code a bit fast. So I run it. I run that. You remember the BT run, the run that I added the functions and passed this JSON arguments stuff. And then I add the result to this list. And you look at the result, name, rule is tool. What I'm doing, I'm mimicking you when you get back the response from the LLM and run it on your computers and then pass the data. So I'm doing it in the cloud. That's the beauty of it. I like to save the time a lot. So now when I did this part, I come at the end and I look at this part, that if there is any, I think this one can come out of the for loops. Yeah, this should come out of the for loops. I found a bug. So anyway, then when I handle all the resolve, then I look at, is there any unresolved left? Because if it's not, so that's it, finish. Right? So just send it. And you remember that when I was here, where is it? This is the case. I just call it and I get the whole thing. So now I have the result. Let's back to this one, because I already called and I got the answers. So I have it and I send it back. Now, but what if there is unresolved? This is the part that we're going to talk about it. Okay. So if as you can see, if it's not, just take a look here. If there's no unresolved, this means that I'm done here. Now I can go for the last part, which is synthesizing the response, right? And that's why what I do, I add these new resolved responses to the context and I leave it to the next components in the pipeline, which is, if you go down, is actually the tool response handler. We'll talk about that. But what if we do have unresolved issue? We should fix it. So then what I do, simply, I create the typical OpenAI response for the tool, which has objects create, and the choice, you see the content is none. And here I have just unresolved tool calls. I missed an O over there. But also I added a new key by myself, resolved. You remember the resolve, right? When we were doing this example here at the end, I said if there are resolved means already proxy called them. So add it to the messages by yourself. That's what is happening here. And then I send it. So that's it. And I send it back to the clients. Why I'm sending back to the clients? Because we need clients or users or end users to resolve those unresolved responses. So that's it. So we got this tool extraction handler, which start to create that, do that prompt engineering. And I told you that instead of doing a lot of complicated things, just let model talk. Just instruct the model to generate the structures at the end, and then you extract it. And then we go for tool response handler. This is when we get the second call from client, and this time the client executed those functions, user executed, and then passed the results in it, and then we send it back. So first we check is tool response. Remember, is tool response is meaning that what would it mean that? Meaning that the last message role is tool, and there is a tools. You know, that's the difference. I take them out, and there is something very important here. If I send this to Groq, I will get an error because Groq says I don't understand what is the rule tool. For now, doesn't understand it, right? And because Groq is not in Groq is not a large language model, is an inference engine. So it doesn't need to focus on this one. It's something like this proxy should do that. So what I do here, I know that Groq as of now has Mixtral and Lava and Gamma, and none of them has these tools, understanding of the tools. So what I do is I manipulate a little bit. And I do it in a kind of a little bit heuristical way to avoid some issues. But let me explain to you what is happening. I go through all the messages. Every message with the rule tool, I change the rule to user, but I augment the content. I have this function. So let's go and see this function. Okay. So look at this function. What this function does, it add a system message colon, and it add the function call result. Okay. Remember that these are tool messages. That means their content is the result of the function, which is a JSON. And I add it there, and then I put a kind of simple explanation. And the explanation says that these are just results of function call, and then use this result to answer the user last question. And in the system message, already I explained to model that whenever you see any message, even if the role is user, but it starts from the system message, this is not the user message. This is something guide. You know, I started to do this back 6-7 months ago when we were working on the projects to have a chat environment with large language model, but with multiple users. It means that if there's a one instance, but there's a students, teachers, advisor, and LLM assistant. And then on that side, we instruct the system message to, hey, if every message starts by the role of the person sending you that message, to understand it and communicate properly. And it works perfectly. So users call in saying this. A user is calling, I need teachers to help me. And then the teachers comes. So we build another model to decide which role should come and then discuss, okay? And similar to what is happening here. And then conversations goes on and goes on. Here, same thing is happening. So there is a system message, we call it guidance message, I don't know, whatever, or Oracle, like a Matrix movie, telling you, hey, you know, that's the answer. But anyway, we're back again here. So I augment that one, and then, boy, I'm doing this again for the last message. I think we don't need this. Yeah, we don't need this. This part can be removed. I will do it later. And then I got to try and catch and then call this one is just a normal route, right? The normal route. And when I don't pass anything for the model, by default is the router model. And then compute it and then get it back and send it back. Finish. Boom. However, if it's a default message, is not tool response, I send it back to the next one, which is the default completion handler. And default completion handler, just call it and then send it back. Nothing else, nothing more. So this is tool response handler. And we discussed about default handler. And I feel hungry. Sorry. And then, you know what? Okay, and then what we're gonna do is, let me see what else I wanted to talk about it is, okay, now a provider, I talk about it, provider is there. This is the proxy. Okay, so just let me, before go to the proxy, just quickly, a quick recap. So we're using chain of responsibility. We have the context that process all the kind of data, especially built-in tools, and then extract messages and tools and prepare everything for the rest of the chain. Then we have this provider selection handler, which look at the provider from the context and then dynamically call the provider. And I show you we have provider classes. Each one has a road functions and get a not a get a schema road. and then we go to tool extraction handler, which is the most important thing. It get into the game if the last message role is users and we have tools. So it goes through the tools, take them out, and do that prompt engineering magic, extract it tools, and then look at them, and then those on if among them some of them are built in, run it, get the results. If there's no any unresolved, just send it back send it to the next components in the pipeline. If there are some unresolved, generate that standard tool response, which we expected, and add it, and then also add the key resolved, and then send it to the users. The users can get the result. Maybe in the futures, I add a Redis ability to keep the resolve, and you no need to send the resolve data through the internet to make it faster. But I think it's good for users to have the options to get it or not, because they can do some sort of post-processing over this. Then we have tool response handler, which get whatever comes from the previous step, either user resolving those unresolved issues, or it's all built-in. Look at them and then try to change the role and that manipulation of the role and augment the prompt and then pass it and get the results and boom, and I send it to default. So that's the whole idea here. And then I have this proxy router. The proxy router is just simply, it's good to see proxy router. I'll tell you why. Because in the proxy router, first I get this provider. So I check the provider. And then if provider handler does not exist, I just generate an error. I take the API token. You see, I'm not saving API token anywhere. Well, you can run it locally as well. And then I get a JSON and then create the context and pass the API token there. And I create my components here. So first I create a provider selection handler. Then I create tool extraction handler. And then I create tool response handler. Well, what's happened to the default handler? Oh, I forgot. And all of my test was with the function call. So it means if you send a message, just a normal message, well, we may get a problem. But I think fallback handler will fix it. Yeah, fallback handler. Anyway, I will add another one, the default one. So that's the benefit of explaining your code to other people. One way of finding bugs. And then I have this set next. You see, I'm building the chain. I can make it in a for loop as well, while actually, but it just simply. So I have to add another set next default handler and then set next to fallback. And finally, I get the first components and run it and then get back the result. So that's about a proxy. And then I don't think these are, and this is the main, which is just a fast API main functions. That's pretty simple. Yeah, it's simple. So that's it. I hope you enjoyed. I hope this can help you because internally really help us. And I really want to invest on this and focus. And if you are interested, please join and let us to build this largest function hub, FunchyHub, and then improve this because there are a lot of cool stuff we can do that. Especially imagine when there are a lot of other multimodal and this kind of stuffs and audio, all can go through this kind of and because this can help us to add whatever we love to Groq, because I don't see Groq team should do that. The focus is very obvious. The chip itself, it should come better and faster and hopefully cheaper, and they bring more models in the game. So such a kind of proxy can be a very good match to such a kind of beautiful products. I hope I can contribute in that way. So that's it. I have nothing else. Please let me know. Again, this hasn't tested. If you found any bug, make an issue and let me know, and we go through it and we help each other. And yeah, that's all. Perfect. Love you all. Have a good day, night, wherever you are in this planet Earth. Uncle Code out. Star Trek.